To say elephants are amazing animals is the mother of all understatements. Their size, intelligence, memory, and sociability are just a handful of the things we admire about these ancient beasts. However, if there is one thing about them that stands out above all else, it has to be that incredible trunk. Part nose, part hand, and part multi-purpose tool and weapon. The trunk is one fascinating piece of anatomy. But where did it come from? What kind of circumstances and environments stimulate the evolution and development of such a body part? Well, that's exactly what this video is going to look at. So sit back and let us regale you with the tale of how elephants got their trunks. Where did the trunk come from? Elephants and their kin have been around for an extremely long time. The major grouping of elephant and elephant-like animal families is the order of Proboscidea, which first emerged around 50 million years ago during the Eocene. Proboscidea is itself part of the Tethetheria clade, which is also home to aquatic creatures like sea cows. So basically, elephants and sea cows likely share common marine ancestry. The early proboscideans all lived in what we call Africa today, and many if not all of them were at least partially aquatic too. They were also tiny compared to the multi-ton elephants we have today. One notable example is Mauritherium, an animal estimated to have averaged a 28-inch shoulder height and a 500-pound body mass. Bull African elephants, in contrast, can be anywhere between 12,000 and 20,000 pounds and stand 13 feet tall. In fact, fossil-based reconstructions and models suggest animals like Mauritherium had a stronger resemblance to the South American tapir than any modern elephant. During these early days of the proboscideans, most of the world was a lush tropical realm with dense vegetation and loads of rainfall. Even the frozen North and Antarctica were within the planet's tropical zones before continental drift and climate change shaped the world into what we know now. That's right, even the Arctic and Antarctica once teemed with rich trees, shrubs, and undergrowth. For about 20 to 25 million years, most of the early proboscideans stuck to the confines of Africa and Arabia. Then, sometime in the late Oligocene and early Miocene, 25 to 20 million years ago, some of them migrated north, then east and west, into Europe and Asia. The animals were well suited to the new lands, and over time, they fine-tuned their adaptation and continued to thrive. Many scientists believe they could migrate because they had evolved into fully terrestrial animals, less restricted by a need to stick close to their home water bodies. By the Middle Miocene, some of the Eurasian proboscideans that had moved east found the Bering Land Bridge, which once connected the Siberian Far East to Alaska and North America. As they migrated, the proboscideans evolved and diversified into uber-successful groups of herbivores. The Gomphotheridae family was the most successful of these proboscidean groups in terms of both distribution and sheer number of species. In fact, modern elephants are descended from Gomphothere species. One of the evolutions many species in the Gomphotheres went through was the development of immense physical size, which placed them firmly in the megaherbivore category. This new size granted them the power to fell trees for fruits and roots and reach food items beyond the reach of other herbivores. Of course, some proboscidean species were still small. This meant several places and environments had proboscideans in various ecological niches. Of course, proboscideans' faces were changing too. During the Oligocene-Miocene migration period, proboscideans started developing longer upper and lower jaws, and some species developed tusks that protruded from them. Over time, these jaws grew longer, and with them, their tusks. Their noses, which sat directly atop the upper jaw, gradually got longer too, and started resembling the elongated nose of the tapir. However, many proboscideans' noses soon surpassed the tapirs and were starting to look more like the elephant trunks we know today. One of the earliest proboscideans with an elongated trunk was Paleomastodon, which lived between 34 and 23 million years ago. This beast was about 2/3 the height of a man and sported two short, downward-curving tusks on its upper jaws. Its trunk hung less than half a foot below its lower lip. From there, the proboscideans ran with the concept of elongated jaws, tusks, and trunks, with many different iterations of this facial setup. One of the most iconic prehistoric proboscideans was Platybelodon, one of the shovel-tusk Gomphotheridae creatures that lived in Africa and Eurasia during the Middle Miocene. Platybelodon had an elongated lower jaw tipped with two sharp teeth, while its trunk was significantly longer than that of Paleomastodon and closer to the length of modern elephant. Trunks. This giant's extreme lower jaw is believed to have worked as a shovel, scooping up undergrowth and water plants. More recently, dental wear analysis suggests Platybelodon also used its massive lower teeth to peel bark from trees. Additionally, modern biologists speculate that Platybelodon was one of, if not the earliest proboscideans to use its trunk for grazing. The general idea is that the animal would grasp the tips of grasses before mowing them with its sharp lower teeth. Other long-trunked proboscideans included the likes of Gomphotherium and Chaerolophodon, both of which had markedly shorter lower jaws than the shovel tuskers. The trunks of these animals were dexterous too, and used to perform all sorts of tasks that involved grabbing, pushing, and pulling. Now, there is one environmental factor that might lie at the heart of why elephants, their ancestors, and extinct cousins developed their long and deft trunks: grass. You see, while it's easy to think that proboscideans developed trunks to help them reach leaves and fruit high up in trees, the truth may actually be the opposite. Here's why. During the mid to late Miocene, the same time period many proboscideans were developing long trunks, the world was undergoing some intense ecological changes. Climate change brought hotter, drier conditions, and in turn, seasonal rainfall. This new climate could no longer support tropical forests and swamps all over the world as before. Instead, the seasonal cycles above and below the tropical zones favored grass. Soon, vast expanses of Africa, Eurasia, and North America became sprawling grasslands. To adapt to this, the mega-sized proboscideans had to develop an efficient way of picking up and eating low-lying vegetation, and that efficient solution turned out to be their already elongated noses. By the end of the Miocene era, some proboscideans were forgoing forest environments altogether and sticking to the grasslands. Again, dentition backs this theory up. Fossil evidence shows that, over time, proboscideans developed ridged molar teeth, a grazing adaptation common among herbivores. This means they were eating a lot of grass, and that they had developed an effective way of going about it. The long-trunked grazing proboscideans went about their business for a long time until they had to adapt again. Around 7 to 6 million years ago, global temperatures began dropping as the world headed for the Ice Age. During this time, a lot of grasslands dwindled, and with it, the range of proboscidean species in the world. Only the hardiest of them survived, and these went on to evolve into the mighty mastodons and mammoths that defined the Ice Age and the days of early humans. Armed with their trunks, mastodons and mammoths were diverse feeders that could exploit both grasslands and forests whenever they could. However, the harsh conditions and predatory pressure exerted on them by humans meant that the heyday of proboscideans was well and truly behind them. One by one, ancient species, genera, and even entire families were wiped off the face of the earth, leaving us with echoes of this once diverse and far-reaching order of mammals. Today we have only one proboscidean family remaining, Elephantidae. Within that, we have only 3 species: the African forest elephant, the African bush elephant, and the Asiatic elephant, and a handful of subspecies. The 2 African elephants belong to the genus Loxodonta, and their trunks are characterized by 2 finger-like tips. Asiatic elephants belong to the Elephas genus, and their trunks have only 1 finger. An elephant's trunk is wondrously diverse. It is strong enough to lift 2.5 heavyweight boxers, yet precise and gentle enough to pick up an apple or even a peanut. Millions of nerve endings and thousands of muscle fibers work together in intricate rhythm to form one of the most incredible limbs in nature. So, as you can see, climate and environmental conditions were the leading factors behind the evolution and development of the elephant's trunk. This adaptation was truly a miraculous feat of nature, and it's kind of scary to think that we wouldn't have elephants today if their ancestors didn't grow and develop trunks. Thank goodness they did. That brings us to the end of today's video. Thank you so much for watching till the end, and we hope you gained a new appreciation for these amazing and legendary animals. Please share your thoughts in the comments. How do you think elephants got their trunk? We also hope you'll take the time to subscribe to the channel and smash the like and subscribe buttons, as this really helps the channel. We also recommend hitting the bell icon so you stay up to date with your favorite animal channel. Until next time, we bid you a fond, furry farewell.